For my model, I've tried to use the approximate dimensions of the flying fish. I've used balsa wood and hollowed out some cavities to be able to have the control system fully on board the fish while it's operating, meaning no wires have to come out the bottom down to the control stem. I've hollowed out a space for the microcontroller. We're all running off a 9-volt battery. We have a small servo motor, and the MEC2406 is mounted to the other side. Because it is a reverse mount to the microcontroller, my math is to take the current heading away from the desired heading to be able to get that inverse signal to be able to push the rudder. As everything is on board, I have put in a power switch down the bottom. I've actually soldered the battery connection straight onto the microcontroller to not have to use the 5.5-inch power pin. Once everything is encased inside the model, once the control system is working, the servo motor drives the push rod off the horn onto the tailplane, which is just attached by a small hinge. The fulcrum is just attached to this rod, and the two sides of the body are sandwiched just with some large washers. We can see the power switch hanging out the bottom, and down the bottom of the pivot rod we can see a small ball bearing encased just in a holder for everything to be able to pivot without having to move the base or hard mount. The only mechanical limitation to this that I've seen is because I've changed the horn location after it goes past about 45 degrees deviation to the left-hand side. It actually becomes an over-center situation with the pivot point and can get slightly jammed up. There is no problems for it going to the right-hand side. Just in our testing, we just didn't push it this far past in any of our experiments to not show that.
This is a program off run of the yawing system. We're just doing this to check the stability. Just set up a little protractor here downstairs with a little indication needle. Indication needle is coming off the actual stem that is bolted to the fish. So I'll just turn the fan on to its highest speed. We've set this just near 90 at the moment, and we can see there's a bit of oscillation, about 2 degrees to 3 degrees with the fan running. Just wanted to do this before the tests actually started, so you'll see the hunting of the fish, even though it's trying to stay around the 10 and the 5 degree mark for test 1. This is test 1 of the yaw stability system. Once the control system is switched on, there'll be a delay of 5 seconds before calibration starts. Calibration takes 10 seconds. The fish should go to a 10 degree approximate deviation to the left, and then after 10 seconds go backwards 5 degrees towards the center. The system is now switched on. Calibration is just about to start. We've gone to approximately 10 degrees. And back to 5 degrees. So the system is successfully stabilizing the fish. You see the control servo is continuing to control the rudder the whole time. This is a run of test 2. Again, the system will be switched on and there will be a delay of 5 seconds before calibration starts. Calibration will take 10 seconds and then the fish should move to approximately 5 degrees and hold. Small indication set up down the bottom to see if when I move the base of the bearing if the fish stays in its correct location.
So the system is now on, it's stabilised, and now we'll be running calibration.
See, we've gone to 5 degrees. And if I twist the bearing base very slowly, you can see it's maintaining that 5 degrees.
See the system continuing to work. Remove the servo motor to control the tail.